Hello and welcome to a continuation of the Y-fillet video I made a while back. In that video, I showed you how to construct a washed out Y-fillets using an overlap approach. And since then, I've received a couple of requests to make an example of the same Y-fillet using the Centerline method. And that is what we will do today. What you see here is the overlap solution from the original video. By the way, the link to that video is in the description. Yeah, let me modify it to a centerline. And if you're interested to follow along, the link to the file is in the description also. So first of all, I will delete the original construction. So as you can see, it was a mirrored solution. So I will leave this part intact just to compare the two methods. And I will delete this one. So I will delete all the surfaces we made, and I will untrim this one like this. So you're going to see these curved surface. That was the original curved surface for this fillet, for this one. And once again, if you're interested how to do this, which is a very simple stuff, refer to the original video in the description. So what I will do is, well, first I will create a tail for the center line, and for that I need to know where the Y-fillet will go. And to create more or less natural transition or natural direction, better say, I will just take the original fillet or the direction of the fillet using its curved surface and extend it and project on this one. So I will duplicate this curve, right? And I will extend it away like this. Then I will project. Let me delete it. And I will use an offset. Now, I will not be probably exact with the same dimensions. I'll just roughly eyeball it. So I will use the curve offset command, and it's supposed to be, I don't know, 2. Let me see, 1.8, 1.8, no, 1.85, 1.98. Yeah, oh, close enough. That's good. Now I will take this surface and untrim it and delete the original solution or original curved surface, which we used in the original example, and just extend it a little bit and trim like this. All right. Okay, let me actually delete all the unnecessary curves from the original construction. Let me delete this and this and this. What do we have else? This one, yeah, let's delete that also. And yeah, I will pick, what? Okay, we have a little problem. So it's not actually perfectly positional. Now with the overlap method, this is not an issue here. It will be an issue. So these two fillets, when they touch together, they're not necessarily supposed to be collinear, or this edge supposed to be collinear, but I will talk about that in the end and show you the differences between my approach and some other approaches which you might already saw on YouTube. But what's important is that it's supposed to be perfectly positional. So let me snap it here. Okay, now we are working with the pretty tight tolerances. So our tolerance for position is 0.001 millimeters. So this is very tight. Now, I will take both of those. Now, important to note, the direction of these fillets was natural to their construction. Now, once again, refer to our original video, but that was originally constructed this way. They, move much further, and then they chop them off. And I chopped them off using their isoparametric domain space, and this is the natural direction for them, and I don't want to change them. And this is really important later. I will explain closer to the end. So I will isolate, and even though that it's not collinear or whatever, I don't bother about that. Instead, I will just create two standard blend curves. Nothing fancy, just a standard 5-degree blend curves. And here I will create a span through them like, oh, sorry, the span the skin right through them. Now, you're gonna see that the characters of both of the lines are different, right? And the control vertices are not perpendicular to each other. Now, in general, this is not an issue. In fact, if that will be a surface which just supposed to be connected to one end or another, that's how it's supposed to be. You shouldn't change it, because this curve and this control vertices, they space this way using a specific tangent and curvature scale to maintain the proper acceleration. However, because we will be projecting this on a surface, and the surface right now is not even positional to them, it's not a big issue to make our life a little bit easier and actually tweak the positions of the control vertices, so it will not actually harm us in any way. Actually, it's actually beneficial. So I will align it a little bit. I don't want to be exact or spot on, just roughly like this, right? Then I will delete these curves, don't need them anymore, and I will bring more degrees. So instead of 1, I will bring 5. It will be continuous. Now I need 5 because I will be projecting it on the both sides of our original model, right? One on this one and one on this one, which is trimmed right now. So I will pick it, isolate, and align. I will align it to the edge, edge align, edge align. So I actually made a video about the edge align and the skew align. What's the difference? But very, very briefly, when edge align, it doesn't mean it means that it's not only continuity constraints applied within the body of the surface, but on the edges as well, right? So we will take continuity from the trimmed edge, so that will properly follow. Now I switch to G2 and edge with the position influence set to 1. To 1 means, the position influence 1 means that we are actually collinear in position, and the curvature, of course, will follow to the original direction of the surface. Okay, these are out of the way. I will delete the history and bring everything back. And let's pick these, and these, and isolate it again. Now, as I said, we need to create a tail. Why we need to create a tail, I explain closer to an end. For now, just please stay with me here. So what I'm going to do is I would like to create a surface, which is a single surface, or not two, but one, which actually will be merged between the two different slabs or different parts of the model, and being continuous to the proper direction, right? So how big it's supposed to be? No one actually tell you, but in general, the general rule of thumb, it's supposed to be shorter than the actual transition. But the actual ratios, it depends. It depends on the curvature, it depends on your model, it depends on the tension. You basically eyeball it. So right now, I will just take this surface and using the extend command, extend with merge turned on. So extend, extrapolate, and merge, right? That's hotkey for me, of course. And I will just click and drag it away, like maybe something like this. I believe that will do. So it's a little bit shorter than half a distance, and I believe this is more than enough. Once again, I will explain why we need that so badly, this separate part, a little bit later. Now I will use another extend with the same settings. So extrapolate and sorry, not the same, different one, with extrapolate but not merge this time, right? And I will pull it back, and you can see now I have a second surface which has the same parameterization as the original one, right? Same direction, its curvature, and so on and so forth, right? Okay, now we have two pieces. Okay, now I will untrim this original part, which we use just to align to the proper direction. I'll trim it here, and I have two pieces. Actually, no, let me untrim it fully and see, do we have any curves and surfaces? We have. Let me actually do it like this, and then trim it like this. Oops, trim. All right, good. Okay, now what I need to do is I need to take this tail surface and I will align it continuously to this part and this part, right? Let's do that. So using align command, project with position influence set to 0, This is in a one direction. You see the edge direction will be skew. This is important for us because we don't want to realign the edge being the edge of the surface, the trimmed edge, or just the domain space of the surface. We want to keep it as it was original, and Alias will try to do its best to maintain the same original direction and structure. We need this. So now we will do the same here, like this, and we will have ourselves a tail which is continuous to both surfaces here and here. And of course, let me select the surface, delete the history of alignment, untrim, and quickly check, and it is continuous here as well. All right, now I will delete this curved surface. This curved surface was an original one from the original fillet. Let me just delete this like this. This is the new one, by the way, for the tail. And here we don't have a curved surface here, right? Yeah, we don't. Okay, cool. So now we will take these segments and isolate. Now the method called centerline, because in general you need to construct the centerline first. You create the centerline or the curve between the connection over two fillets and to the end somewhere there, align it, create it, and then create two separate surfaces which will merge and become to be continuous, which is quite tricky actually to do. But there is the same approach basically, so we still need a center line, but we will do it a little bit differently. So first of all, what I'm going to do is I will use a point, just to mark a space on the geometry, and I will use the offset command. I'm using the offset insert command with other type of span, not curved surface, but a span. Click, drag, then hold Control and click on the point which I constructed, right? So now you're going to see here that it placed, well, here. Why here? Because this is the shortest distance between the 2 points, right? And that's more or less the proper position, at least at this side of our span. Now I hit spacebar, and I will construct a span for this surface. Now this surface has 5 degrees on U and V directions, and it has one span in U and 2 spans in V. Okay, cool. Now, immediately after that, I will go in and I will use the command called NURBS to Bezier, which actually deconstructs the multi-span surface to a single span surfaces, right? Using the spans as a cutting and reconstructing tool. So I'll hit spacebar. There's supposed to be original one. This is the original one. I will delete it. And this is the 2 new ones, right? They are continuous between each other, of course. And they are not necessarily continuous here. They're not even continuous. They're actually not positional. Well, why? Well, because when we deconstruct it, well, the operation of deconstruction and rebuilding of the surfaces, it actually works within the specific tolerance, and it's not always identical. This is the one reason. The second reason, and I believe this is quite obvious, is that this surface is now aligned and this one was straight. That's why you're going to see that we have some discontinuities here, and they're not positional because these ones curved and these ones still not. So the next part, let me actually delete the point here. Let me delete the point. The next part will be to align both of those, right? So I will use align command. I will use edge align, position influence set to 1, and click on the edge. Here is a very important part. This side supposed to be edged aligned because we need to maintain continuity across the edge following the edge of the original surface, but the inner one shouldn't be. You're going to see where it goes. It want to go following this direction. We don't want that. We want to work with our center line, which is now basically an edge between two surfaces, right? So I will click on skew and it will try to maintain the original direction. All right, okay. It's not exact, but very, very close. Now let's do the same on the other side. So click, click. This one is skew, this one is edge. And once again, we have ourselves a curvature. Once again, curvature, edge, position influence set to 1. Okay. Now let's go to the other side, and I will basically do the same. I will go in and I will align this to this, and you're going to see that immediately when I'm aligning, it aligns to the whole surface. I don't want that. So I click partial. And what is partial? Same thing, it's closest distance. This one will be skew, this one will stay as edge, and I will do the same here and here. This one edge, this one is skew. Okay, now I will delete the history, and I will look at the results. So this one is curvature, this one is curvature, these two curvature. This one, however, is not. Well, it's tangent, which is great, but it's not curvature. Now, right from the get-go, about the center line. So as you're going to see, if I will use a duplicate curve, right, you're going to see this is actually our center line, right? We didn't construct it manually, we constructed through the span. However, even though that here it's in the proper position, here it is not. Why? Because when we separated one big surface on two parts using the, well, biased position, we basically split it on two equal parts based on the surface itself, but not on the actual, not the surface, sorry, the character of the surfaces, because this one is pretty small, right, and cramped. This one is much bigger, right? So, and it just inherits this through the surface, and you're going to see that they are connecting to my tail, not specifically in the middle, right? Maybe you're designing that, but in practice you want like a 50-50 or close to that balance. Otherwise, the smaller fillet, if you have, because in our example, these fillets has a different size. If they are the same size, it's easier, but in this case, they're not. And if you will keep it like this, then we will inherit this crampiness of the smaller fillet, and it will look odd. So instead, something like 50-50, we need to merge, right? That's why it's called Y-fillet. So we need to merge them together in a kind of like in a 50-50 balance. So what I'm gonna do is I will use the patch precision tool, click and drag. It gives me the isoparametric lines of the domain of the surface, so I know that this is roughly the middle. And then I will use the command called extend. So I use extend command again, and this time with merge and extrapolate turned on. I will click on this surface edge, and I will just drag it. I can be very spot on. I can place a plane, the point. I can snap it here, but actually, we can do it like roughly. That's okay. So, and I will push it down. Then I will do the same here, and I will push that down here as well. All right. Okay. Oh, sorry, that's the wrong command. Like this. Okay. So, so basically we realigned our center line a little bit. Now what we need to do, we need to align everything else. So what I'm gonna do is I will realign that again. Now, why we did realignment first if we move this stuff? Well, because it always gives us, every single iteration gives us the closer and closer approximation to what we actually want to get. So this control vertex is already skewed in a very specific direction. So now I just need to specify a little bit more what it's supposed to be. So once again, skew edge on one side, here align. Now you're going to see here that it tries to align to the whole. Same thing, it's partial alignment, edge skew, right? And we're doing the same here. So this will be skew edge, and this one partial alignment, partial skew edge. Let me check once again. Skew edge, yes. Skew edge and skew edge. Okay, let's check. You can see that we have a slight deviation in the gap because when we slide it, we change the character a little bit. That's fine. What we're gonna do is we'll use the G0 with the position up, so just align it here like this. Now, what's next? We will delete the alignment history yet again. I will bring everything back, and I will, what is this, the curves and surface? What is this? It's not a curve and surface. Okay, so what I'm gonna do is I will project both of them on their correspondent surfaces. So this one will be projected here, and this one is supposed to be projected here. Let's do that. So project, G2. Position of one set to 0. Both will be skew. We don't want to change these directions anymore. They are very arbitrary. So I want to let them be as they are originally. Same here. All right. So you're gonna see this one stays curvature. This one probably not. No, it's still is curvature. Okay, now let me trim this. Delete the history once again. And now we will focus on the center line. So if we click here, you're going to see that's not even tangent, right? And in most cases, this is something you will probably struggle with, right? So everything up to this point is pretty easy and self-explanatory. So what are you going to do next? Now, what I prefer to do in this case is, first of all, look at the control vertices. And you're going to see, let me just kind of switch to the different mode. So you're going to see that the control vertices are distorted. So these ones, these two rows of civs and these two rows of civs are very different. Why? Well, because these surface, our tail, is actually the perfect natural blend between the two. This one tries to inherit the character of our fillet, and it was much narrower because it was constructed with the, I believe, the factor of 0.5, meaning it's pretty punchy, right? And now we have a pretty abrupt transition. This is not great. It will give us like a hump on the highlights. So I can manually adjust it before moving on, or I can just delete the. I already deleted the history. I can use the command called plane erase holes with the best fit adaptive with a single. I prefer to do it one by one and just see what it gives me. And just and remember, history of alignment is supposed to be deleted at this point. If it will be kept, like so, for example, here or there, then the whole planarization can give you a horrible results. It will try to balance it with the continuity, and it will be a mess. So delete the history first. So now I will just click and I will try to straighten it up using the adaptive method of straightening the holes. Isn't perfect. Once again, it's always better to do by hand, but it's good enough. So when we did that, of course, we may lose the continuity, and we did. Here not, here yes, here yes, here yes. And what we need to do, we need to do it again. And once again, we're not doing it for nothing. Every single time when we are aligning, we shaping and shaping and shaping and form closer and closer and closer to the result we're really looking for. So multiple realignments is a common tactics. So once again, position flow set to 1, align here. Let me check that it's supposed to be skew and skew. It is. Here, skew and skew. This one is not curvature, so let me delete. Let's align here now using edge. Position flow set to 1. Let's switch to these modes with position influence and edge. Okay. We are now released curvature here. That's fine. Okay. Skew and edge. Okay. Once again. Yeah, edge. Okay. Here is good. All right. Now let me delete them both again and do the final projections here. Or final, maybe not final. Right. So this is the projectile line, and you're going to see that we have deviation now. So because we realigned it here and it's supposed to be continuous, now here we don't have the proper continuity. However, the difference is very minuscule. So probably if I'll just jiggle this around, it can give me the proper result. It will not. That's okay. How about this one? This one works. So right from the get-go, what it tells me, and by the way, I'm doing it with you right now. You know, I'm capturing it in one big session. So if I'll do some mistakes or something is not right, and I will be doing it in front of you, because I believe it's really important to see that even professionals sometimes do different iterations and multiple iterations, and this is normal, a part of the process. So you're going to see that this one is not continuous, and this one is not tangent. Now, because this one is not tangent, what I try to do is I will try to check quickly, is it even possible to construct the proper shape I want, to continuous everywhere with the proper character, having surfaces with 5 by 5 degrees. Maybe I need 2 surfaces, or maybe I need 5 by 6 degrees, or 5 by 7 degrees. I don't know. So to check it out, I will now align as a curvature with the position influence set to 1 and check. And you're going to see that it's, no, sorry, that's supposed to be skew, and that's supposed to be skew, right? And when I check it, you're going to see that I wasn't able to achieve tangency. Let me just kind of delete all the unnecessary garbage here. You're going to see that I wasn't able to achieve tangency with the proper directions. What it tells me, the difference is really small, but it's there. it tells me basically, so if I will push it hard enough and a lot of CV adjustments, I will probably be able to make it work. However, in practice, it doesn't really how it's called, like make sense, because your time is limited. So instead of doing that, there is no crime to just add additional degree. Now, don't go overboard. If you need more than 7 degrees, that's probably it's supposed to be 2 different surfaces, or you did something wrong. Here, what I'm gonna do is I will revert. I will take my surface and I will bring additional degree. So not here, on U direction, here. And I will do the same for this surface. Remember, this surface failed to be continuous on this side. Now it's just for some reason not, but I believe that's because we are now in 5 degrees, yes. So you're gonna see that additional degrees was really important for us. All right, so now let's try to align, and now we have tangency with like this, right? So now we have tangency, and the curvature deviation is, well, let's say relatively small, 0.1. It's not a lot. It's definitely something we can tweak by just CV massaging. Now, how about this one? This one is losing tangency, which is not surprising. This one is losing curvature, which once again, not surprising. All right, so let me pick, let me actually kind of switch the view. Let me just take this one. No, let me take this, and this, and isolate. Okay, so now let's focus on the center line, because everything else, everything we can could possibly do, we already did. These two are curvature, and we have a couple problems for this shorter part, right? So we have an issue here. So this issue comes from this center line. If you remember, just a minute ago, a couple of minutes ago, I slid it to the left. But the fact that I slid it to the left, I made this edge proper for our transition. And this one, the original one, is in the proper position too. But no one tells you that all the other control vertices are on its proper places. And in fact, if I will look at the construction, you're going to see that some of the control vertices are actually in the wrong positions. Like, look at this one, or this one, right? They're actually going down. They shouldn't go that aggressively down. It's just too much. This is definitely an issue here. And the issue are either with the actual center line, the actual cut, or with the supportive tangent and curvature rows. So we need to fix that. And we fix that by maintaining the alignment. So as you can see, alignment type is edge with position influence set to 1. I will keep it like this because it means that these rows of CVs are collinear, tangent rows are collinear, curvature is following. And now by changing these points, or this one, which is will be automatically picked by from the left surface, I can actually tweak the right side. All right, it's pretty common tactics. So what I'm gonna do is I'll probably take this control vertex and I will push it down. And by pushing it down, you're gonna see that the vertex, this one, is actually going up, right? And it's supposed to go up. I don't want to have a dimple here. It's supposed to be roughly more or less a naturally transitioned, right? So that's what I'm gonna do. Now you're gonna see that the curvature deviation is even bigger right now, but I'm not bothered about that anymore. For now, we'll fix it a little bit later. So let me say something like this maybe. Let's look at this row. And I just need to be sure that my curvature is still intact this time. It is important right now. I don't want to realign it anymore. Okay, so as you can see, this one just brings me the deviation. Let's try to bring this one up instead. Right, you see, when I'm moving it up, I have this kind of the zigzag line. That means that both of them are actually failing. So that means that we can, let me actually do this one a little. Let me just push it a little bit, like maybe to the left. Something like that. I'm just looking at the curve, just eyeballing it. Is it really in the proper position or not? All right, let me take these one, see how the tangent row is doing. I would say that it's roughly in the proper position. This one is probably also, so let's try this one. Yeah, so you see, when I'm moving this one, it's actually really aggressively changing the curve. However, and this is the problem with the center line, because you need to balance both of them. You're going to see that these row of CVs is actually in the proper position. It's good. So the only thing I really need to tweak is either these one, these one, these one, or these one, right? So let me just push this one up like that and try to remove this problem. Okay. Let's try to balance it with this one. Maybe like this. Let's say this one is okay. Okay, let's continue. Let's try to move this one a little bit around. No, this one. And so some of them are still off. Maybe I need to just rise them a bit. No, it's just too much. But this control vertex, maybe these ones a little bit. No, it's fine. Like really want to be a little bit tighter to this side, right? I'm looking at this row right now. I believe these ones are okay. So it really wanna go down, but I really don't want to push it down. Let me try to kind of align it here in this direction instead. Maybe a little bit more here. So I believe they're still a little bit kind of cramped. Yeah, I believe there is no other way. So let me just then push that up. And then these one just push down instead. And then just balance with this one. All right, that will do. Let's look at the. Let's look at this at the back. So here we have a problem. No, here we don't have a problem. What's about this one? Well, that means that one of the control vertices is just going down, supposed to go up, right? So which one? I don't know, maybe this one? Yes. Maybe one tangent row, one curvature row like this. A little bit down. All right. Okay, so I will delete the history, bring everything back, quickly check that this one and this one is curvature. Let me now isolate and trim. Let me trim this one here, 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 and here. Or actually, you know what? No, I will isolate this, untrim, and I'll just delete this curves and surfaces. I don't need that, like this, okay? All right. All right, and we actually done. So let me quickly check everything. I will show you the result, compare, and then I will tell you why I built it this way instead of any other way. So let's check the zebra stripes. With the, what is my tolerance for tessellation? Let's bring it higher and look at the result. Here we go. This is our fillet. Now you see, if I will change the tolerance to something small, we're gonna see that it's just all like sharp. Well, it's just the quality of the tessellation of a mesh in a viewport, nothing else. So the higher it is, the more accurate the readings will be, right? And that is a pretty good result. Now here is our fillets with the standard shading, and you're gonna compare the two. You're gonna see that they are pretty similar. However, this one is a little bit bigger and thicker. Well, that's probably I just made it in a slightly different direction or orientation than this one. And here is the another shading type. All right. So that's how it works. Now, let me quickly explain why I built it the way I built it. Now, first of all, I've already briefly explained the tail. So tail is extremely important for us, and this is the standard for Centerline. Everyone will create a tail because tail gives you an ability to create a perfect blend, a most natural blend between these two. And because this is a washed out fillet, it's supposed to slowly and gradually wash itself out into the surface of choice. That's why this separate surface is so important, and it's not the part of the original construction. Now, important note that what I often see is that what people try to do is they will try to create the tail at the very end, and they will try manually bringing spans, bringing additional control vertices to basically match it as close as they can to the collection of your original fillets. Don't do it. There is no a lot of reasons of doing that. It doesn't mean that you can't. You can, but it actually defeats the whole purpose of creating a tail, because tail must be natural transition between the two. Doesn't mean that if you will do this way as some other does and try to construct it a much more complex in the beginning and then pull it away, it will make your overall the final result worse. Not necessarily, but you will spend much more time on doing that for no particular reason. Another important thing that after that, and I said it in the beginning, I did nothing to my edges. My edges, as I said, were natural to the fillet. They depends on the type of the fillet and the edge construction in the middle, automatic, perpendicular, edge align, so on and so forth. It just inherits that. And the fact that they are not collinear is not an issue. I see a lot of people try to overextend, find like the middle ground, construct the line, trim, reconstruct. They are losing the history for these fillets. They're losing the tolerance for these fillets. They need to align everything only to maintain a straight line. Well, it's not beneficial, because at the end of the day, it's not about the straightness of the line. It's about the character which you transform and the direction and basically the curvature from one surface to another surface with a skewed angle. That's what important. This angle is skewed, and because it's skewed, there is no particular reason of trying to do all of this kind of mumbo jumbo to make it straight. You can. It will work. It just, once again, as with the tail, you don't need to do that. It's kind of like that doesn't serve any purpose, mathematically speaking, and logically as well. So this is another thing. The third thing, as you're going to see, I never built a center line myself. I relied on a span because, as I showed you, really briefly, people construct a curve or a blend curve or a curve or blend curve with position and curvature on one side and another side, or the manual alignment, whatever, and then they will try to fiddle with that, so it will just kind of merge with this too in terms of the CV placements and things like that. It doesn't mean that you can't do it. Once again, you can, but it takes additional steps and additional efforts, something which you rarely have in practice, because in practice you never have enough time, and you need to be fast and efficient. So instead, relying on the control vertices themselves is actually a much more beneficial approach. Now, is this a final construction in general if we are talking about the actual practical sense of this? Well, in terms of the quality, yes. It's good enough for what it is, and it will definitely work for consumer electronics. When it comes to the cars, if this is not necessarily cars, if this is a big model, right? Because this one is tiny, it's very small. But if we're talking about the car, right, it has a big, prominent parts, and then of course you need to go in and just do a little bit kind of additional steps to make sure that this stuff works right and there is no issues with this. First and foremost, you probably will go in and instead of relying on automatic whole alignment, you probably will do it manually, or after that, right now, you go in and you will do your manual adjustments, right? So you're going to try to make it a little bit more accurate. Like, for example, here you're going to see that this control vertex, right, it's not in the proper spot, right? So if I will go in and I will try to just, kind of align that. Sorry. This, right? You're going to go in and you're going to straighten your holes. You will see that there is no additional stretching right here and there and everywhere. You will try to be it's all good and great. However, once again, in practice, you rarely have time for that. So if this is a big one, a big model, you will go for it. If this is a small model, you will leave it be. This is more than consider it as a good result, because everything is curvature and everything is smooth. You don't have any additional humps on the end, so everything looks like a charm, right? So, and final notes, which method is better? If you watch my original video, you know that I'm a big fan of the overlap approach instead of a centerline. For reasons I explained in the first video, but in the industry, different designers do different things, and creating the fillet using the centerline is absolutely a legit method to do. A lot of people do it. However, in practice, because it's very demanding in terms of the topology, on a very big and aggressive turns and bends, you will not be able to do it in a single surface, of course. There will be spans. You'll forced to bring spans separated in different chunks and so on and so forth. It will become to be a pain in the butt, let's put it this way. However, yeah, it's doable. So both methods are here, and we'll just use which one you prefer the most. In terms of the visual appearance and the actual nature of what Y-fillet is, I still believe that the overlap is true to what Y-fillet is rather than the centerline. All right, guys, that's it. Thank you very much for watching, and I will see you in the next one.